All right, so starting off, let's just review some properties of exponents. What do we do here? A couple different ways we could approach this. What's probably, like, what might be the best way? I could just distribute that exponent. Okay, but I could also flip it. Good. I'm going to suggest flipping it before you distribute the negative, right? If I have something to a negative power, how can I rewrite that? Put on the bottom to the positive third power, right? So everything inside the parentheses is just going to stay the same, but it's going to go on the bottom to the positive 3. Give me thumbs on that. Does that make sense? Okay, so first step then would just be taking care of that. So I'm going to get the quantity 6x to the 4th y cubed to the positive 3 on the bottom times 5xy. And where could I put that 5xy then? It's just going to go on the top, isn't it? Because if I multiply these fractions straight across, that's just going to go on the top, isn't it? Right? Okay, so then what's that give me on the bottom? I have to distribute that exponent to how many different factors? 3, yeah. What's the first one? 6. Good, so I'm going to get a 6 cubed times x to the 4th cubed times y cubed. What's that give me on the bottom then? What's 6 cubed? 216. What's x to the 4th cubed? X to the 12th. Take a power to a power, you multiply exponents. Y cubed. Y to the 9th. Good. So the last issue then, we can't reduce that fraction, but the last issue would just be how do I simplify that if I'm dividing like bases? What does x divided by x to the 12th end up being? Say it again. X to the 11th where? On the bottom, right? And remember the shortcut rule. The shortcut I showed you guys is when you're dividing like bases, you'll keep the base where it has the most power and subtract the other exponent, right? So there's really an invisible 1 there and an invisible 1 there. So this is just going to give us on the bottom x to the 12 minus 1, x to the 11th. And then what about the y's? What do I end up with? Yeah, good. Y to the 8th on the bottom. And that's my answer. Okay, good? All right. Okay, this is really kind of a freebie, isn't it? What are we doing here? Yeah, I'm just evaluating the function at 7. So P of 7 is just going to equal 7 squared plus 7 plus 4. Well, that's 49 plus 11. What's that? 60. Okay, no big deal. Okay, so describe the end behavior of this function. How would you describe that? Positive or negative, odd or even? Negative, odd. Show me with your arms. What's negative, odd look like? Yeah, it's like that, isn't it? Good. So all we care about here is the leading term. And that leading term is doing that. That's it. Okay? Nope, good. Okay, now graph the polynomial. So with this one, we need 2 ingredients to sketch this thing. What are they? Say it again. Okay, the x-intercepts. Good, I need x-intercepts. And then what else? What else do I need to get this sketch? I need the x-intercepts and their multiplicities. We'll get to that. But I need one other clue. I need end behavior, don't I? Yeah, good. So if I were to multiply this whole thing out, what would the first term be? X to the what power? Well, I'm going to get from this part, I'm going to get an x squared. From that part, I'm going to get an x squared. I've also got an x out there. So what's the power of x going to be? Fifth. Yeah, I'm going to get x to the fifth. And I'm going to get my leading coefficient is just going to be -1, right? So does everybody agree my first term is going to be negative x to the fifth? Okay, give me thumbs on that. Does that make sense? Okay, if I multiply this whole thing out. So then what is that end behavior? Positive or negative, odd or even? Negative odd. So that's going to be up, left, down, right, isn't it? Right. So we know we're doing that. Now I just need the x-intercepts. Well, what's the x-intercept associated with that factor? When is negative x equal to 0? When x equals 0, right? Anytime you have a monomial factor, the x-intercept or the 0 that goes with that is always 0, right? So we get x equals 0, we get an x-intercept. What's the multiplicity of that one? 1, right? Because I have a 1 there, so multiplicity is 1. So what's it going to do at that x-intercept? Cut like a line. Okay, how about this guy? What's its x-intercept? When does x minus 2 equal 0? 2. What's the multiplicity? So what's it do? Bounce. Good. And then finally, how about that one? -3. Multiplicity? What is it? 2. Good. So that's going to bounce again, right? So we should be able to put this thing together then. So we had a green x-intercept there. We had a red one there. And now we should be able to graph this guy. So we're up to the right. We're bouncing at the green x-intercept. So we're doing that. We're turning. Now it's got to cut through at 0, so it's got to do that. And it's bouncing at red. And then it's down to the right. So everything fits. Okay? That's what the picture's got to look like. You got to just pick the one. I'm not going to have you graph any of these on the test. You're just going to be choosing the correct graph based on the clues that you establish, right? Okay, so there's that guy. Let's see, I thought I had, did I not have another one of those? Nope. Okay. Well, I guess this guy, yeah. Okay, so what about this one? It wants you to find the real zeros. So what are the real zeros of this function? -7 and +3. Good. Okay. So what's the which is the larger of those two? 3. What's the multiplicity at 3? 1. Yeah, because it's to that factor is to the first power. What's the multiplicity of the smaller, which is -7? 2. Okay. Because it's squared. Good. So then at the larger x-intercept at 3, if the multiplicity is 1, is it touching or crossing using their language? Crossing. Okay. At the smaller, which is -7, we had a multiplicity of 2, so it's what? Touching. Good. And then what's the maximum number of turning points based on, now what would the leading term be on this thing if I multiplied it out? X cubed, right? So the degree is what? 3. So what's the maximum number of turning points? 2. It's always 1 less than the degree, right? So that one is 2. Okay, there is another part of this that I didn't include on the review here. What is the power function that defines the end behavior? Same thing as the leading term. Negative 8x cubed, right? That's the term that tells us the end behavior. Does that make sense? Okay. Okay, this one, these are just piece of cake, right? We're just adding and subtracting terms. The first two, nothing is being distributed and there's no exponent, so all I do with the first two is just eliminate the parentheses, right? Six x squared minus 4 plus 6x squared plus 4x plus 4. Now what do I have to do on the third one? Good, I've got to distribute the negative, which gives me plus 8x squared. Good, and then all I've got to do now is just combine like terms. So how many x squareds do we get total? 20 looks like, right? 6 plus 6 plus 8. So I get 20x squared. How many x's? 4. Yeah, there's only one x term, right? So plus 4x. And what about the constants? Negative 4 plus 4 minus 6. Minus 6. Good. Okay? Good, good. All right. Okay, what do I do here? What's that mean? I see that. I see the universal sign for distribute. There you go. Good. So we're going to distribute the 8a. 8a times 5a squared is 40a cubed. Okay, so in my mind, I know that's the biggest power of a. I'm going to carve out columns for every power of a. So when I add up like terms, I can just group them vertically, right? 8a times negative 5a. Negative 40a squared. Good. 8a times negative 8. Good. Negative 64a. And then what do I distribute next? 7. 7 times 5a squared. Okay, so that goes in the a squared column. 7 times negative 5a. 7 times negative 8. Good. And then all we got to do is add up like terms. So 40a cubed, how many a squareds do I get? Negative 5, so minus 5 a squareds. How many a's? Positive or negative? That's it. Okay, good? No big deal. All right, last, we got some patterns to deal with. Okay, I guess I gave you the answer there. What's the pattern that this fits? Okay, that's what it equals, but what does it start with? Like, what does this match? A plus B quantity squared, agreed? Okay. Where A is equal to what? Oh, but what's the A equal to? 8x. What's the B equal to? Good. Now, what is that pattern, the quantity A plus B squared? A squared plus 2AB plus B squared. And then all I've got to do is just substitute my values of A and B and simplify, and I'm done, right? Piece of cake. So this just becomes the quantity. You can't forget the parentheses there. It's the quantity 8x squared plus 2 times the quantity 8x times B, you told me was 2, plus 2 squared. Good. So what is the quantity 8x squared? Good, I got to square the 8 and square the x, so I'm getting 64x squared. What's 2 times 8x times 2? Good, 32x, and then plus 4, and we got it, right? No big deal, okay? What is that pattern going to be? Which one does that match? Yeah, the quantity a minus b cubed. Good. Okay, where a is equal to 2x, b is equal to, no, 3, right? If we're going to use, oh, and that's the wrong pattern, isn't it? Whoops, sorry. I see why you said -3. That was smart. Yeah, we could do it that way. Could do it that way, right? But we could also just use this pattern if we want to, the pattern a minus b cubed, where b is 3, because the negative sign's included in the formula. Okay, so I'm probably going to have to fix this formula as we go here. So you tell me, what's this formula, the quantity a minus b cubed? A cubed minus a squared b. Okay, so I got to change that to a minus, don't I? Whoops. Okay, next term. Good, and then finally minus b cubed. Good, so I got to fix that one. Or we could have just done the original pattern, a plus b cubed, where b is -3, right? Either way would have worked. Okay, so now if we make our substitutions here, that's going to be the quantity 2x cubed minus 3 times the quantity 2x squared times 3 plus 3 times the quantity 2x times 3 squared plus, or minus, oh, why did I put 2? That's supposed to be a 3, isn't it? 3 cubed. Okay, what is the quantity 2x cubed? 8. Got to cube the 2, cube the x. What is the quantity 2x squared? Okay, so let's multiply 4x squared times -3 times 3. 36, how about, yeah. X squared. 3 squared is what? Okay. So 3 times 2x times 9. There you go. So plus 54x minus, what's 3 cubed? We got it. Okay, give me thumbs. All good? No big deal. Okay, last one. What about that guy? Okay, what's the first pattern we see? A plus b times a minus b. Okay, good. So now with that pattern, a plus b times a minus b. What's my a? Ah, good, the whole thing, right? So a is that whole quantity, 9s minus 1. What's b? 4, yep. What is that pattern? Okay, and you told me that A was the whole quantity, 9s minus 1. Minus b squared is just 4 squared, right? Okay. Now what? What pattern's that? Yeah, that's A minus B quantity squared, isn't it? Right? So here's the pattern. A minus B squared. What's my A? 9s, good. Oops. What's my B? B is 1, good. Okay. And A squared minus B squared, what is that pattern? Okay, and we know what those are, right? A squared, that's going to be 9s squared minus 2 times 9s times 1, right? Plus 1 squared. And then don't forget, we've got this minus 16 out there at the end, don't we? Right? So now if we combine all those like terms, what do we get? What's the quantity 9s squared? How about all that stuff? Negative 2 times 9s times 1. 1 squared minus 16. Got it. Good? Okay. Good work. All right. I'm going to shut her down up here, and I'll let you guys just continue to work and prep for things.